Hello, 1C class. Today we are going to do 13.7, okay? This is still for March 23 lesson, which is a Monday, tomorrow. We're going to learn about tangent plane, okay? What's a tangent plane? It basically, if you have a surface, a 3D surface, if I'm going to find a point P, okay, going through P, I can draw a tangent plane. The orange color one. The tangent plane, we use the formula equation, okay, it's a f of x at minus x at 0. Also, where's the f 0? It's the point for p. Okay, p is made by x0, y0, and z0. So f of x is come from the gradient of the vector that perpendicular to the tangent plane, okay? And this f of x, del f is come from the surface, the function of surface, okay? The function of surface is g equal to f x y. You need to change to f x y z equal to 0. That means you take everything one side, other side to be 0. And then you take the partial, that's where you get f x, f y, f z. And then use this one as your vector for just like when we do the plane, we have the directional, we have the vector normal to the plane, so that is the vector normal to the plane. Okay, f x, f y, f z, and then x0, y0, z0, just the point on of P. So when we get a plane, okay, the first thing to do is to change to this format first. And the most important, the one good thing about this is that when we the normal vector, we no longer need to find the cross product of two vectors. Okay, we just find the gradient of the surface, then that's it. So let's see the example. Number 12. Okay, you are given a surface function, and that's equal to g, and that's equal to x squared plus and minus 2xy plus y squared. And at the point 1, 2, 1, so that's your point P. They said find the tangent plane that going through that point tangent to this surface. Because this is not in the formula of this one, it's in the formula of this one, so you need to change to this first. Okay, you said let f x y z equal to subtract z on both sides, just like how we did. I think we have one session we have to do like that also, subtract z. Okay, now we're going to get f of x, del f is equal to f x, f y, f z. And which is equal to f of x equal to 2x here, 2x minus 2y. And then fy we have negative 2x plus 2y, and fz just equal to negative 1. And now we're going to put the points in here. So del f 1, 2, 1 equal to, so I put the point inside, I get negative 2, 2, and negative 1. So these are the vector, the normal vector, this is the normal vector, okay, it's a coefficient for that. So we're going to go negative 2, x minus 1, plus 2, y minus 2, minus 1, z minus 1 equal 0. And I'm going to simplify it, okay? It comes out equal to 2x minus 2y per z equal to negative 1. So that is the equation of the tangent plane, okay? Going through this point and tangent to this surface. Let's try the one. let's look at point number 28. Number 28, you're given two surfaces. One is a z equal to x squared plus y squared. Okay. One is a z is equal to 4 minus y. And at the point 2, -1 and 5. They said, here's what they want to do. They said find a set of parametric equations for the tangent line. Okay. Now this one, if you remember, it's actually like a bow. Okay, it's like a bow. You just we don't need to draw it, but you just kind of get some idea what is it. Okay, and then there's a plane. Okay, cut through the bow. So this is a, we draw this a plane is a, this is a, this one. Okay, z equal x squared plus y squared is a elliptic bow, elliptic paraboloid. I don't say that was right, but it was a one when we learned in 12 point, I think it was a 11.6 or 11.7, 11.6. And then z equal 4 minus y, it's just a, when z is equal 0, y is equal 4, so let's say this is a 4. When y equals 0, z is equal 4, let's say this is a 4. So it's a parallel on the x direction. Because x is missing. If x is missing, that means a parallel to x direction. Okay. And you can see that they intercept. Okay. When they cut it, obviously it's going to be, there's some intersection. This is a broken line. Okay. And when you cut through the bow, so there's a, they intersect each other. Okay. And then from the intersection, there's a point, a tangent point. So because so what we need to do is we're going to find the gradient of each one of them, okay? And then we're going to take the cross product, and you're going to have so when you cut through it, so let's say for this part, there's a gradient for the bow. It's like this, okay? There's a gradient for the other one, for the red plane. So it's like this. And these are two gradient. It's an intercept each other. So this is for the first one. So let's say that, let's give a name, okay? Let's let f x y z equal to x squared plus y squared minus z. So for the first one. And then I'm going to find the gradient for that one equal to 2x, 2y, and then minus 1. So that's the first one. And if I put the point inside 2, 1, 2, -1 and 5, it comes out equal to 4, -2 and -1. Okay, now I'm going to find the gradient for the red one. So this one for del f. I'm going to give a name for this one. I said that's a del g. Okay, so I'm going to let g equal to 4 minus y minus z. And del g will equal to x is at 0, and this one's a -1, this is also for the y is a -1, for the z also -1. So now I'm going to, you can see when I take the cross product of these two, I would have a vector coming out like this. Okay, because cross product has a perpendicular to each one of them. So this would be, and you can see that cross it will be tangent to both of them. Okay, so it's right here. So that's a tangent one. So del g f cross a del g And I'm going to go I, J, K, and 4, -2, -1, 0, -1, -1. To save my time, I'm going to tell you, so we know how to do this one, right? And I'm going to tell you this is equal to 1, 4, -4. Okay, you can check it out on your own. Okay, just like how we did the finger. So now once you get the cross, and then this will be the directional vector for the tangent line. Okay, so the first step of parametric equation will equal to 2 plus t 1t. Okay, y is equal to -1 plus 4t, and z is equal to 5 minus 4t. So that's for this format. You can also do a other format. Okay, you can also do the symmetric format. So that be up to you. So you can go x minus 2 over 1 equal to y plus 1 over 4 equal to z minus 5 over -4. So that's for these problems. And the last problem I want to do is about if I'm going to have a tangent plane going through the bowl, well, they definitely have a little angle between the two planes, right? So what's the angle? So the last thing in this session is about find the angle between the tangent plane and the surface. Okay, so let's say I have a surface right here. It's just easy for me to draw the plane. And then I have a tangent plane, okay? And so that's my tangent plane. Touch the surface. And then they form an angle right here, so I'm going to call theta. And there's a vector perpendicular to my original plane, my original surface, okay? So I'm going to use this always a K. And I have one that perpendicular to my tangent plane, okay? So I'm going to go use N. You can see if I extend this, and then if I extend this one, and this angle here is also theta. Okay, so extend this vector here, extend this vector. Okay, this angle same with that angle, and they said now K is just equal to 0, 0, 1, right? You know that. And the formula to find the theta is a cosine theta equal to N dot K. And we learned this before. And the length of N, the length of K. So now, use this formula, we're going to do examples. Oh, by the way, one more thing, you can see your N is just equal to gradient if this function is f, okay? It is an f function here. So let's see like example number 34. And there are 2xy subtract zq equals 0. This is at the point 2, 2, 2. So first we're gonna let, okay, f, we're gonna in this format first, okay? We are given the format this way, but we make it to be like that. So we let f x y z equal to 2xy minus zq. And then we're going to get del f. At this point, your del f is the same as your n because it's perpendicular to this surface. Okay, I'm going to put down perpendicular to that. So del F at this point just equal to N. It's just equal to 2x divided to x, which is a 2y. That's a 0. Divided to y, that's a 2x. Divided this one, just a negative 3z squared. Now put the number inside here. And it comes out equal to 4 and negative 12. Now put in the formula for cosine theta equal to, oh, I forgot the formula, sorry, this is the link. We just take the positive one, and it's equal to n, so we take quadrant one only. N is equal to this one, okay, 4 negative 12. That's case equal to 0, 0, 1. And 4 squared plus 4 squared plus negative 12 squared. And then it's just a 1. It comes out equal to 12 over square root of 176. Use your calculator, and theta approximate to 25.3 degrees. Okay, so that's how you do if you want to find the angle between the tangent plane and the surface. And that wrap up today's lesson. So hopefully you guys all, Wednesday I will have a 13.8. That's a long lesson, so I'm going to break it 2 parts also. And then I will office hour on on Wednesday. See you there.